Man-in-the-middle attacks using bridged interfaces and Wireshark to see the benefit of all that hard work. Let's begin. Our objectives in this nugget are simple. Basically three things. In a previous nugget, we looked at having Bob as a customer, for example, and having a man-in-the-middle attack. So all of Bob's data went through our computer. Well, that's fantastic. Well, what do we do with that data once it's right there going through our computer? And I wanted to focus, that's our first objective, is take a look at Wireshark and how we can actually analyze that traffic if we want to see those packets that are going through. Secondly, I also realized that there's lots of different ways to do a man-in-the-middle attack. In our first discussion of man-in-the-middle, we actually used DHCP services, we had routing set up, we were doing network address translation. It took quite a bit to set up. I wanted to share with you yet another option for implementing a man-in-the-middle attack, but instead of setting up routing and NAT, we can set up bridging. What do you mean, Keith, bridging? You mean like cards? No, bridging as in taking two logical interfaces and putting them in the same broadcast domain. The concept of bridging is not only simple, it's brilliant. Check this out. Normally, we'd have, if we had two interfaces, we'd have two different networks we were connected to, two different IP networks. Maybe this is the 2 subnet, this is the 1 subnet, and that's how it works. And previously, when we had our interface AT0, which was created by Airbase coming up as an access point, we assigned this guy an IP address, and that was the default gateway we handed out via DHCP. With bridging, what we could do is forget that concept of having two different interfaces and two different IP addresses. What we could do is we could go ahead and bridge them together like this. We could take the logical interface that represents the access point, the physical interface on the backtrack system, and bridge them together. Now we're also going to create this logical interface. They call it a bridged interface. And we're going to give it an IP address. Let's say 192.168.1.50 or some other IP address that's on this subnet space. That's because we still want to be able to communicate. We still need to have an IP address that we can use from a backtrack perspective on this Ethernet wired space. But by bridging these interfaces together and using a logical IP address, check out the beauty of this, my friend. Now, we have that same user, Bob. We trick Bob into associating with us, no problem. And now when he associates with us, he does a DHCP discover, saying, I need a DHCP server. That discover packet, which is logically coming in through our AT0 interface, because these interfaces are bridged, guess what happens? It gets forwarded out the Ethernet 0 interface and over to our DHCP server. The real one, the one that we're using, or could be using potentially. So in this case, Bob's packets are just switched. This is like a layer 2 switch. Think of it that way. And we're just forwarding the packets back and forth. We still have access to all the traffic. We can still see it. We're still man in the middle. And this is just a lot easier to set up by doing bridging as opposed to setting up the full features of DHCP yourself and also doing the NAT on this interface. So on our list of commands, we're going to start up our monitor interface. We're going to go ahead and see what's out there on the wireless network. We're going to start our access point. So these three error commands, we've used them several times, but the BRTCL, that's the command we're going to use to create a new logical bridge, and then we can add the interfaces we want to that bridge. So we're going to add this interface logically to a new bridge, and we'll give that bridge interface an IP address so that we can still communicate off of this Ethernet side. And once the traffic is flowing from Bob's computer through us, whether we are using a DHCP server ourselves and natting as in the previous nugget, or whether we're bridging as in this one, we can still see all of Bob's traffic that's coursing through the veins of our backtrack system. So here's the backtrack system, my virtual machine that I've been using for each and every one of our nuggets in this series together to this point. And here's something that I discovered. I discovered that when you emulate hardware, not everything for every single purpose is going to come through the way that we had hoped. So here's what I found. I found that with my virtualized machine, I've got my Ethernet 0 that we've seen many times. I've got the wireless LAN 0. Which, as you know, goes out to my Alpha card. And the Ethernet 0 is actually bridged to a wireless card internal inside of the host machine. But here's what I discovered. When I did the actual bridging between the actual AT0 and Ethernet 0, all the commands took, everything went great, except for one little detail. It did not work. So I thought to myself, oh my gosh, I wonder if it's just my virtualization. And it was. So I have a second machine that's a real laptop. It's like a 6-year-old IBM ThinkPad Lenovo machine, has a built-in wireless adapter. I fired it up with Backtrack. I ran the apt-get, as we all should occasionally, both the update and the upgrade to get it up to speed where this Backtrack system was. I went through the steps for setting up the bridging, and it worked like a champ. So here's what I would like to do for this, because I had a couple options. I said, well, one is I can go ahead and set up a whole bunch of remote X windows so I can get remote control of the GUI on the old machine, but that might taint the actual configuration because I'm messing with the actual IP addresses as I'm trying to manage that device. So here's what I would like to do. This, my friends, is the document that is in the NuGet download area that has all the commands that I used for this. What I'd like to do is walk you through them step by step. And let me make all these a little bit bigger. So we'll change the font, and there we go. Fantastic. Let me walk you through the step by step of what I did. I first of all said ifconfig. Why? Why, Keith? Why do we do that all the time? Just to verify that the hardware we think is there and available to Backtrack is. We then started the monitoring interface. So I said airmon-ng start wireless LAN 0, and that creates MON 0. If we did this again and again and again, we'd have MON 1, MON 2, MON 3, MON 4, etc. And you can use each of those logical monitoring interfaces to kick off separate logical access points, which is pretty cool as well. Then we use AirDump to verify what's on the wireless, to see what the access points are, what their SSIDs, what channels they're at, their signal strength, and also the MAC addresses. And then we actually launch our own access point. So in this case, I launched an access point. I call it test 2. It was on channel 1. So that was all honky-dory, all up and running. Now I had this access point just waiting for people to associate with it. However, the problem we had in that previous nugget was we have to set up DHCP services, we have to set up network address translation, everything else to actually route that customer's traffic through us. So here's what we're going to do. We're going to go ahead and bridge this logical AT0 interface and our Ethernet interface. And I added this just for, fun. You can do ifconfig AT0 just to see that that interface is there once you have Airbase running. And then we're going to create a bridged interface. This, my friends, is a logical interface. brctl is the command, add bridge, and then I just use the name. You could call it Bridge 5, you could call it My Bridge, you could call it Tony, whatever you want to name it. It's just a label of a logical bridge interface. Now, what good is a logical bridge interface? Well, it's pretty worthless until it's got some real interfaces associated with it to be bound to it. So right here, this says I want Ethernet 0 to become part of that bridge group. I want AT0 to become part of that bridge group. And that, my friends, is how you bridge logically those two interfaces. So now it's like we have our access point logically in the same network as our Ethernet 0 interface. So let me clear off the screen and let me scroll down a little bit and let's continue the party. Here's a show command that can just verify the details of your new bridge group. And then what I did, I said, I want to take Ethernet 0 and I want to go ahead and remove its IP address. Now, currently, my Ethernet 0 has an IP address. So when you do this, if you're using that Ethernet 0 to communicate at that moment, you're not going to be able to communicate. That's why my SSH session would die right at that point. But this says I want to just basically remove any valid IP address from that interface and make sure the interface is up. I'm doing the same exact thing to the logical interface that was brought up by the Airbase command. I want to assign it no IP address and make sure it's up. And then I'm going to assign an IP address to this logical interface. So this BR1, in my case, represents the bridge group. It's a logical interface that contains, if you will, Ethernet 0 and AT0, and I'm assigning it an IP address. So in my case, my real Ethernet 0, it had the IP address of 192.168.1. something. Let's say it was 50. So what I could do here is I could assign this bridged interface that same logical address if I wanted to still use it, or something else on the same subnet. It really doesn't matter. And then I specified that I want it to be up as well. I did a quick ping. Why? I just wanted to verify that it really worked, because once you create your bridged interfaces, you want to make sure that you still have IP connectivity. And then I want to turn on forwarding of packets for IP version 4. All this does, it takes the AT0 and my Ethernet 0, logically puts them in the same bridge group. I called mine BR1. I assigned an IP address of 192.168.1.205, which was appropriate for this network where Ethernet 0 was physically connected. And now Bob comes into play. So the final test went like this. I had Bob, he's our customer. He associates with the backtrack access point that was launched by the command airbase. And once he does, because we have the AT0 and the Ethernet 0 bridged together in a bridge group, it just acts like a layer 2 switch. So he associates, his client does a DHCP discover. That discover request goes all the way through to the real DHCP server that's sitting off of my Ethernet 0 interface. So I'm simply like acting as a layer 2 switch. So there's the discover, there's the offer, the request, the acknowledgement. Bob gets all the information that he needs from the real DHCP server. He has an IP address on the real subnet. He's got the default gateway, whatever that default gateway is on this wired network. He has a DNS information, and he's off to the races. So I set this up. I used the client I associated with the access point that was promoted by the Backtrack system. I thought, what could we do that would really demonstrate how cool this is? And I said, well, let's use Wireshark. Now, Wireshark, if we have already launched the GUI with StartX on our Backtrack system, if we just type in Wireshark, it'll bring it up. I'll show you that here in just a moment. So I brought up Wireshark, and it said, hey, do you want to start listening? I said, you betcha. Let's listen on Ethernet 0. Now, we could have picked any interface we wanted to. We could have picked AT0 or Ethernet 0. But I thought, you know what, there might be a lot of other wireless noise going on out there. Let me focus on Ethernet 0, and that will not share with me a whole bunch of other wireless noise. I can focus on any sessions that Bob is doing or that I might be doing as I'm sending traffic through my own Ethernet 0. So then I thought, well, what could we demonstrate that would be pretty significant? So I had this computer, I had him log on to an FTP server. Ouch. And as he connected to that FTP server, the FTP server said, I need you to authenticate. And he did. And FTP, unfortunately, just like HTTP, it's all plain text, not encrypted. And as a result, Wireshark caught all of that. And so what I did was I took that Wireshark capture, I moved it over to my current Backtrack system, and we can take a look at it together. So that, my friends, is the process we can use to set up bridge groups for doing the same man-in-the-middle attack, but not have to set up DHCP services or any types of NAT to get it to work. So back at my virtual machine that was willing to sit out this one while I did it on a physical laptop, to bring up additional console sessions, you just simply click on the window for a terminal session. And to run Wireshark, for example, you type in Wireshark, just like that. And once Wireshark launches, it'll bring up the graphical user interface. It'll give you a message about, hey, do you want to run this as root? I say, heck yes, I do. And then down here, it's going to just give me a list of all my possible interfaces. Here's my Ethernet 0, for example, and I could go ahead and click on Start, and it would start listening to all the packets on that interface. Look at that. I've got some traffic flowing right there. So this is what I did on the standalone laptop. And then I saved the actual output. So let me share with you the file that I actually captured during that attack. And it's right here. It's called FTP capture. I'll double click. It says, how do you want me to open this? And it's a Wireshark file. So I'll type in Wireshark. It'll open it up. Give me that warning about running it as root again, which I'm going to say, don't bother me about that again. It's okay. So with Wireshark, we can go down through all the packets and see all the details. It's pretty fascinating. I love Wireshark. It's a great teaching tool. It's also a great forensics tool to find out what really is going on the network. But here's a feature that I absolutely love. Let's say we're looking for FTP. So in this protocol column, I'm just going to go down to FTP until we find it. So there's some DNS, some ARP, there's some spanning tree in there. Holy cow. Scrolling down. There's our FTP. So on FTP, if I simply, there's another FTP here. If I right click on that, I can simply say, I want to go ahead and follow the TCP stream for this. And by clicking on that, it'll take all those FTP packets, organize them for me, because it's all plain text. Look at this. So I was connecting to a 3COM FTP server version 2.0. The user was Bob. It prompted me for my password, and here's the password that I put in. Secret password. Not so secret anymore. And unfortunately, any text that Bob sends, if it's not encrypted, I will be able to capture that as the man in the middle. And of course, we would never want to do anything like this and reveal people's passwords unless we had full authorization to do exactly that. I remember being at DEF CON, and they had, it was like the sheep wall of shame. I forget what they called it, but it was a huge display and that, well, of live captures of all the people, even at DEF CON, who are using plain text passwords for HTTP and FTP and other protocols, and they were displaying portions of those passwords. They have it blacked out, part of it because they didn't want to get in too much trouble with it. But it's amazing what individuals will do as they send passwords across the network in plain text and not have even a second thought about doing it. In this nugget, we've taken a look at yet another way of doing a man-in-the-middle attack with wireless, this time using bridged interfaces as opposed to routing it as we did in the previous one. We also identified how we could use Wireshark to eavesdrop on that data that's going through us, and we also pointed out that if we want to, we could actually run Airmon NG several times to start multiple monitoring interfaces. What's the benefit of that? We could use Airbase several times to bring up multiple access points. And that might come in very handy. For example, if we know the access point name, but we aren't sure if they're using WPA or WEP or Open Authentication, maybe we could bring up 3 access points, one of each flavor, with better chances of entrapping the client. I have had a lot of fun in this video. I'm so glad you joined me for it. All the commands that we used in this video are in that file in the Nugget Lab download area. If you want to go ahead and practice it, that'd be a lot of fun. Again, make sure you're authorized for whatever tools you're using. Make sure you're using them in an authorized way. I hope this has been informative for you, and I'd like to thank you for viewing. The Network Mapper, or as his friends call him, Nmap. Back in 1997, Gordon Lyon created a port scanner that has grown and evolved over the years to become one of my personal favorite tools in the world of network reconnaissance. I would put it in the top 5 of the tools included in Backtrack. Without further ado, let's dig in to Nmap. I'd like you to imagine that you and I have just been hired on by a large corporation to support their network infrastructure. And they told us we're not really clear on all the workstations. We have some Mac, we know. We have some Windows. We might have some Linux. We don't know exactly what's out there. That happens a lot in many, many companies. So we come on board, and our first question is, okay, what exactly are we dealing with? What type of operating systems do we have out there? How can we figure that out? Well, one of the tools that we can use to do that is called Nmap. Nmap is a free open source security scanner. It's a port scanner effectively with like a boatload of bells and whistles. See, the magic of using a port scanner or a network scanner of some type is that it knows how devices might respond. For example, if you and I were computers and I sent you a ping request, what might you do? Well, if you received that ping request, you'd probably send an echo reply back to me saying, yep, I got your message, and I would verify our connectivity. So a network scanner could simply send a ping request to a range of IP addresses, and if it got a response, it could identify that those devices are up. Well, some computers don't respond to pings. What else could we do? We could also send out, for example, a TCP SYN request. So if you and I, again, are computers, and I send you a TCP synchronization request, you, being a good TCP citizen, should send back a TCP acknowledgement to my synchronization request. You're also going to send your own SYN. That's what they call it, a SYNAC coming back to me. A scanner could go ahead and simply send a TCP SYN request to a whole bunch of devices, and the ones who responded, for example, if we sent a TCP SYN request looking for port 80, which is the well-known port for web services, those devices that sent back a SYNAC to us would be indicative that they are running that type of service. So the magic with a really good port scanner is that it knows how to ask a question, and then when the response comes back, it can interpret that. So Nmap has in its large arsenal of options the ability to identify the operating system that's running on that device, identify what services based on ports. We can specify how fast or how long to wait for those responses, and that's a great, amazing tool to discover what is out there on our network. In this video, you and I are going to take a look at getting up and running with Nmap. And it can give us more than just what devices are on the network. We can ask Nmap to retrieve for us the operating system that's currently running, or the version of that operating system that's running, and a whole boatload of other options. So after we're comfortable with the basics of how Nmap operates, I'd like to introduce you to something called NSE, the Nmap Scripting Engine. And what this does is it uses a special collection of scripts to gather even more detailed information from various hosts. And the great news is we don't have to write the scripts. Nmap comes with literally hundreds of them, and there's more on the internet that have been written by other individuals for special purpose needs that we can go ahead and download and simply leverage. Everything up to this point right here has all been the command line interface, character-based. There's also a graphical user interface front end for Nmap, and it's called ZenMap. It's also built into Backtrack, just waiting for us. So if you want to use either method, you'll be prepared for accessing either one. So let's start off with some basics. If we needed to get help with Nmap, what could we do? Well, Keith, we could probably just type in Nmap, press enter, or maybe Nmap --help or something to that effect, and it would give us all the possible options right on the money. How else could we get help with Nmap? Well, Keith, we talked about earlier how you could use the man pages, man space Nmap, and that would bring up the entire documentation for Nmap. I just want to remind you that help is just a few keystrokes away, and I would strongly encourage you to go ahead and take advantage of it. So let's start off with some basics. Let's use Nmap and point to an IP address. Just to remind you, all of the addresses that I'm going to be using in this demonstration are machines within my control that I personally put on the network. So the basic syntax, here, let me get my pen out, is Nmap, and then you simply point to an IP address. Now, we also could have done a range. We could have said 192.168.1.0, and we could have put a dash and 255, and that would do the entire range. Another way we could have done it is said 192.168.1.0/24, and that would be the entire subnet of 192.168.1. Or if you want to do a single host, you can just put the IP address in just like that. I'm going to unpause the screen for a moment, and here's the results. It says it took approximately 21.66 seconds. It found that SSH, Telnet, HTTP, and HTTPS were all open on that system. It also is saying, based on the MAC address, that's a Cisco or a Linksys device based on the first half of the MAC address. It also shows us here that it scanned approximately 1,000 ports. I say approximately, exactly 1,000 ports. It found 1, 2, 3, 4 that were open, and there was 996 that were closed. Now, that's the default behavior with Nmap. It's going to scan that device for 1,000 different ports, TCP ports, to see what exactly is open on those TCP ports. So that was a good warm-up. Let's go ahead and go to another window. I've got multiple windows open so we can keep them nice and separate. Let me show you another option. We have Nmap-SP. Now what that is, that's a ping scan. It's not going to go ahead and do a TCP scan of all 1,000 ports on every device. It simply wants to send out a ping request and see who we get a response from. So the dash, lowercase s, capital P, and this address says the 192.168.1, and this asterisk is a wildcard. So instead of scanning just for one host, we're going to go ahead and scan the entire subnet. So this could be rewritten as 192.168.1.1 through 254 or 255, that's the broadcast address, or 192.168.1.0/24, and they would mean exactly the same thing. Again, just like our previous example, if you want to scan one exact host, simply put in that one IP address and you're set. So there's multiple different ways to describe the fact that we want to ping this entire subnet. So we'll simply do a enter, and it's going to scan through that entire subnet and bring back all the responses. Now, all these, wow, look at that. This is on, so I've got 16 hosts that are reachable on my subnet right here. And it's giving us the vendor's name based on the MAC addresses. And it's simply because the MAC address associated that came back with that IP address, we're simply using that to determine the actual vendor. So that's where this list is coming from on the far right here. So let's go ahead and have Nmap ask a little bit more detail than just, are you there, or with these 1,000 ports. Let's go ahead and use another option. So here, let's take a look at some of these options. And literally, there's hundreds of options with Nmap. And these are some of the ones that we might be using periodically. So right here, this represents what we want to do, a TCP SYN scan. We're looking for TCP devices using SYN request. Here we have P0. And P0 is referring to a protocol scan. So protocols have numbers. So for example, in the TCP/IP protocol suite, ICMP is protocol number 1. TCP is protocol number 6, UDP is protocol 17, etc. So this is saying, please go ahead and do a request on each of those protocols by the numbers to see who responds. The -SV says, I want to go ahead and determine the version, if possible, of the operating system that's running, and this -O is representing that we want to discover what that operating system is, again, if possible. Based on what Nmap is asking and the responses that come back and the way that Nmap is looking at those responses, it can identify most of the time the actual operating system vendor. Is it a Mac OS? Is it Snow Leopard? Is it Mountain Lion? Is it Windows, Windows 7, Windows 8, etc.? What flavor of Linux is it? Most of the time it can get that and the version if we simply ask Nmap to ask the right questions. And here we're specifying the range of 0 through 50. Now, there's nothing at 0 because that's the actual network address space, but that's the range we're going to query in, and the responses we get back will be displayed on this screen. Now, this one, because we're asking more of Nmap and it's got to spend more time in getting that information, this may take a few minutes to complete, but that's no problem. We'll go ahead and let it run in the background. So while that's cooking, it's like a cooking show. We'll let that cook in the oven. Let's go to another tab and let's run this one. This is Nmap-T5. Now, what exactly is T5 all about? So the syntax here, the T5 is regarding timing. How aggressively, time-wise, do we want to go ahead and do this scan? So a T1 would be giving the response lots of time before we gave up and move forward. A T5 says, you know what, I'm in a hurry. I don't want to wait that long for responses. So a T5 is going to make it slightly faster. And in this case, I'm using the example of scanning the entire subnet of 192.168.1.0/24. 24 meaning, of course, it's a 24-bit mask. The first 24 bits of that IP address represent the network, and the last octet, that last number in this case, represents individual host addresses. So we're going to scan approximately 256 different places. Only 254 will possibly be there, and we're looking for all the devices in that space. So let's go ahead and press enter, and let's run our next option. By default, Nmap is scanning 1,000 ports, TCP ports, looking for open services that it can report back to us. If we don't want to look for 1,000, we can go ahead and say how many we want to see by using this option right here of top ports. The syntax is pretty straightforward. It's Nmap -- top ports, how many ports you want to look for, and it's not 20 ports in order like 1, 2, 3, 4. It's 20 of the most likely ports to be up. So if we said 100 for the top 100, it would be the top 100 ports, most popular ports that are likely to be up in a typical environment. And then we're scanning the same network again, 192.168.1. Now, I want to point out that you don't ever want to do this on a corporate network where you don't have authorization to do it, because most corporations are going to have some intrusion prevention systems looking for scans of this type, and they're going to come looking for you. So again, make sure you're authorized to do any of these scans and use any of these tools that we're talking about. So to continue here, I'll simply press enter, and that will launch that scan for us. Let's move on to another window. Let's say we're only interested in finding out who is running web services and is open on port 80. And to do that, there's several different ways of doing that. With one of those options is to specify the port. So in this example, we're doing an Nmap. The -ST is representing a TCP connect scan type of probe that we're going to be doing. The -P80 says we're looking at only at port 80, and we're going to go ahead and do this network range of 1 through 50. So yet another way to represent the devices that we want to do the scanning against by using the hyphen and the last IP address in the range. And so to launch that, we simply press enter. And that's on its way. And that is already done because it took 1.89 seconds. It didn't take a long time because all we were asking for is one individual port, and that was port 80. For this next one, I'd like to run Wireshark, and to do that, we're going to need the graphical user interface. So to get there, once we've logged on as root with the default password of Tor, unless you've changed that, we're going to go ahead and do a start X to start the graphical user interface. To launch Wireshark, probably the simplest way to do it would be to open up a console window and just type in Wireshark and launch it, and that'll bring it up. If you want to use the menu system to get there, we could bring up the menu system, go to Backtrack, and under Forensics, and under Network Forensics, and Wireshark. If you're a lot faster, just type in Wireshark. But let's launch Wireshark, and let's go ahead and let me bring that up full screen. So here's Wireshark. It's asking us to pick our interfaces. In this case, I would like to pick the interface Ethernet 0. That's where we're doing our scanning. And I'm going to go ahead and tell it to go ahead and start the actual capture of traffic. So any of those scans that perhaps are still in place and still running, those would be seen here. Let me go ahead and let's go back to our console window, and let's continue with our next Nmap. So with this, we're going to run Nmap. I'm going to do -S, uppercase S. That's a TCP SYN scan. And I'm going to use the -D option. That's a lot of fun. So the -D, what's that going to buy us? That's for decoy. If somebody is doing scans on a network, your source IP address might be trackable. Well, if you want to get the responses, you need to involve the correct IP address. But to throw them off the track a little bit, perhaps, we can use a decoy. And what this is going to do, it's going to launch the actual request with the real IP address of this backtrack system, but it's also going to do it with these source addresses as well, 98 and 99. So if you include, can you imagine if you put maybe 100 or a couple hundred IP addresses or fed it in from a list regarding all the source addresses this attack, this scan is coming from, it could distract the network admin or whoever's in charge to the point where they wouldn't be able to sort out. There's just too much data. They wouldn't be able to sort out who the real source of the attacker is. So now it's going to be three. It's going to look like three. The IP address of this backtrack system and the .98 and .99. Usually throwing in a critical server's IP address is a lot of fun. Again, only in an authorized network would you do anything like this. So I'm going to go ahead and run it, and that's going to take quite a while to run as well. So here in the graphical user interface, let's go ahead and stop the capture that was going on. And there is just a lot of data that is here. So in that time it took for me to launch the scan and come back here, 11,000 packets have been seen. So what we're looking for is 99, and there we go. Let's just grab one of them. So there's a source address. We can make these columns a little bit more easy to read too. 192.168.1.99 and 98. So we launched the actual scan from 3 different IP addresses, our own and these 2 decoys. If we want to filter on just that one, we can right click inside of Wireshark and say, I want to apply this source address of 1.99 as a filter, and I want to have it be selected. And it's only showing us the source addresses of 1.99. And so if we scroll up and down, there's just, hundreds and hundreds of packets from 99. To clear that filter, we simply say clear, and then we can say I want to see 98. So select 98, right click on it, and then say I want to go ahead and apply as a filter, selected, and that will show you just the 98. So another option that you can do if you want to whittle this down even further is you can say, okay, I want to go ahead and sort it out between 98 and the destination of 1.2. You could right click on this field and say I want to apply as filter and this field as well. Click on that, and then it will only show, so the filter is saying source address of 1.98 and the destination of 1.2. That's a great way to sort through boatloads and boatloads of data inside of Wireshark, is to use filters. And when you're done, you can simply say clear, and that shows you the native output of the entire capture. The purpose of this was just to verify that we really were doing the scans with multiple addresses. So just to verify that the decoy option, the -D, was working inside of Nmap. Let's take a look at a few more options together. This one is Nmap with -V, as in I want to see verbose. Because it was just one device, didn't take a lot of time to accomplish. So it said, okay, I scanned 1,000 ports. So look at everything it found. That's amazing. Here's all the ports it has opened. It has Telnet, DNS, HTTP. Now this is the that's TCP 53. Normal DNS requests are UDP 53, but I think the RFC for it says that that port, TCP or UDP, is associated with DNS, which is okay. And then I have a whole bunch of other ports here that, for whatever reason, happen to be open at the moment on that device. Also, based on the actual MAC address, the first half of the MAC address, it's determining that that's a Netgear. Now, it didn't do a complete operating system and version request. That takes a little longer. This information here is simply based on the MAC address. So as the options keep rolling here, also, by the way, all of these commands I've included in the Nugget Lab download area. So they're right there in order if you want to go ahead and practice with them. Again, I'd remind you, you don't want to run these commands on networks that you don't have authorization to do it on. So the next one I'd like to share with you is the -F. Now, there's hundreds of options inside of Nmap. The -F says, I don't want to scan 1,000 ports. I would like the top 100 ports. That's what -F is all about. And so in this case, we're saying that we want to go ahead and we want to scan the entire subnet of 192.168.1, and I want to go ahead and exclude the 2 devices at .1 and .2. So you have the option of not having to scan everything on that network if you want. So we're including a new option and some various ways of skipping devices we don't want to include in the scan. This one will take a little while, but not quite as long as the 1,000 port scans per host, because this one's just going to do 100 port scans per host. Let's open up a new window. Another option that we have is we can skip the ping process. Normally what happens is Nmap will do pings first. If it gets a response back, it will then go into the port scans. Well, what if somebody isn't responding to ping, but they still have some services open that we want to find out about? The -pn, I think this is the current flavor of the command. At one time, I think it was -p uppercase n. But in any event, this is going to go ahead and scan that one device, but it's not going to bother doing the ping first. It'll just simply do the scan. And there we have it. So it was 1,000 ports that it scanned. Doesn't take a long time to do it. And it has these open. In fact, this is the same machine we looked at earlier. Let's try that again with a different device. Let's go ahead and try 24. 24 is it's a router. It's a different flavor of router. It's not a Palo Alto router. It's some other vendor. So 1.6, it had to reach out and talk to that device. True story. And for 124, it had to as well. This one took 1.43 seconds. This took 20 seconds. You might ask, well, it's the same scan. What were you doing? And that's a good question. Maybe it was slower to respond in this case. So this guy has SSH open, Telnet, HTTP, and HTTPS, and it sees it based on a MAC address as some type of a Cisco or Linksys device. So what about IPv6? IPv6 is slowly but surely making its way into more and more mainstream. It was developed, and born, if you will, more than a decade ago. But now with the exhaustion of IP version 4, people are getting more and more serious about it. So if you want to do Nmap with IPv6, we first of all would need to have IPv6 running on a backtrack system. So ifconfig Ethernet 0, iNet 6 for an iNet 6 address, and then you put one in. Now, this IPv6 address would have to be one that matches the current network. So with IPv6, for most user networks, the first 64 bits are going to be the network. So this is the syntax on how you would apply it. I'm going to go ahead and hit Control-C because I've already applied that address. It's already there. If we do an ifconfig and press Enter, it's going to represent the fact that, yeah, Keith already put it there a few minutes ago. So there's the actual IPv6 address, but there's the actual syntax to go ahead and implement it if you wanted to on your interface. So with IPv6 enabled, if you want to use Nmap with IPv6, you'd just say Nmap space -6, which implies, hey, this is an IPv6 address coming, and then you'd put in the IPv6 address that you want to go ahead and scan. It would also be really important that you had reachability or a default gateway to get to that IP address, and that IP address needs to exist, which at the moment this one doesn't, so it won't be too successful. So my interface ID is 2, this interface ID is 1, and if that device existed, I should be able to go ahead and reach him. So we can press Enter, but unless he's there, there's not going to be too much to see as a result. Another really handy little option with Nmap is the Nmap space --if list, just to give you a nice little overview of what interfaces you have to play with and what their addresses are. So if we take a look at this detail, it says, okay, Keith, you are connected on the 192.168.1 network that's local on Ethernet 0. You've got a default route of 192.168.1.1. And then we have some really cool stuff about IPv6 as well because we have an interface configured for it. Just to round out the exercise, we have the Nmap. Let's go take a look at our results. We have the Nmap with just the IP address, scanned 1,000 ports, gave us some results. This one, if we do an up arrow key, this was the -SP. That was just a ping request. That was very, very quick. It took 3 seconds to the entire subnet. This one, if we do the up arrow key, see what that command was. And this is like the kitchen sink. So the S is for a SYN scan, and the P0 is asking for the protocol number scan. V was for version, O is for operating system. And if we scroll up through the large amount of output for each and every device, so our next one here, if we do the up arrow key, was the T5. That was the very short timeout. It took 54 seconds for it to scan the entire subnet and give us the information it found out about that. Next one over, if we do the up arrow key, this is where we asked for the 20 most likely ports, the 20 most commonly found ports. So it didn't take quite as long. And so it scanned for those 20 ports across the entire subnet. And that took about 6.81 seconds. So in our next window, so in this one, we just did a port scan for port 80, looking for all the devices. It took less than 2 seconds for that response. We already looked at that window. We were doing a scan. It took 7.17 seconds, and this is where we actually did the decoy with 2 additional source IP addresses also doing those. Now, we really don't care about the responses that came back to .98 and .99. We cared about the responses that came back to us. Again, the purpose of the decoy is to throw the person watching the network off the track regarding what our real address is of the real attacker. So I wanted to get a flavor of some of the commands, and in the download area for the Nugget Lab, I've got all of these syntax that I've used in class. You should definitely try them out on networks where you're authorized to do such. Maybe build a test small network and issue them there. You definitely do not want to run these on a production network where you are not authorized to do so. It could get you into serious trouble. So the next thing I'd like to talk with you about is scripting engines. Now, they came up with the idea that if we want to gather information from a device and then start zeroing in, for example, and narrowing it down the specific operating system, or we want to get specific details on what that user or what that device is running as far as SSH services or web services, what type of a web server is it running, and so forth, they wrote these scripts. There's hundreds of them that we can leverage and put inside of our Nmap. So in Nmap, all we need to do is refer to these scripts, and there's various categories of them, and these scripts can go and dig even deeper to ask the right questions to get responses, and then Nmap can tell us the results of those responses and dig out things such as, oh, this is a server type of Mac OS running Snow Leopard, for example, or this is a web server running Apache, or whatever the information is we're after. There's very likely a script already written that we can use with Nmap. So let's begin with scripts and take a look at just how easy it is to use them. Nmap space -- script equal and then the name of the script group that you want. Now there's a default group. So out of the default group of scripts written for Nmap that are already built and sitting waiting for you in Backtrack, it's now launching that along with the 1000 port scan against that device. And here are the results. So it got more detail, not besides just knowing that TCP port 22 is open for SSH. It also has some information on SSH version 1 is supported. Port 23 was open before, not a lot of additional information. Port 80 was open, so it dug a little deeper to get information regarding how HTTP was operating. Same with 443. And it also has some information on the self-signed certificate that Cisco IOS router happens to have on it and is currently using for its SSL services. Now I want to share with you something. We just did this -- script equals default. There's a whole bunch of different categories. There's a DOS, exploit, malware, vulnerability, discovery, safe. There's a whole bunch of other options we can use. But I would strongly encourage you not to start playing with all of these script options unless you are aware of the potential results. For example, there is a script group called safe. Now, does that mean it's safe to run against anybody's network? The answer is no. It's not safe to run against anybody's network. It can still get you in trouble, but it's safe. It's called the safe group of scripts because it is not likely that it will take down a server, unlike some of the other scripts that you could launch, like the DOS script and so forth. Let me give you another example of how we could run this same script, the default script, but not have to use the -- script option. It goes something like this. Nmap space -sc. That is shortcut. That's not what the SC stands for, but that's exactly what it is. The dash lowercase s uppercase c effectively means I want to run script, and by default it's going to run the default script unless we specify some other script. So the previous scan took 26.69 seconds. This one should take approximately the same amount of time. Again, if it's the same device responding, it should be about 26.69 seconds as well. And it's within a second, so that actually is perfect. So now we know that if we want to run the default script, we can use this. So let's say that we wanted to run the discovery group of scripts, but we weren't sure about all the arguments and parameters that we could have following it. There is help as well for the scripts. So if we typed in nmap space -- script - help, and then the group of scripts we want help on and pressed enter, there's about, I don't know if you saw that, but there was like dozens of pages that just flirted by. So we could scroll up and take a look at all the details for that category of scripts. So let's say that we want to run some scripts. We're on our own private network and we want to practice with a few of them, but we want to actually combine groups of scripts. How can we do that? If we said nmap space -- script, and then in quotation marks, we specified safe or default. What that would mean to Nmap is, okay, I know what you want to do. You want to run the default set of scripts and the safe set of scripts, which again doesn't mean it's necessarily safe to run them. It simply means that they're not known or likely to bring down the system that you're running them against. So in this case, the default script, the group only took about less than 30 seconds to run. But because now we're running safe or default. It's going to run both sets. The tricky part for some is the fact that it says safe or default. Which one is it going to do? And let's say you point to a group that doesn't have any scripts in it. Well, for example, if safe had nothing in it and default had the default scripts, it would run default. If you had safe or default and they both had scripts, they will both run. So if we pressed enter here, this one will take quite a while because the safe scripts are going to have a lot of information they're asking for from that device. So if we want to run two, and we had two different groups, like for example, discovery and version, those are both group sets, if you will, for scripts with the Nmap scripting engine, we could say nmap space -- script, and then specify in quotes discovery and version, then specify the destination address we want to run these against. So while that is running, let's go back to this first one that is still running. If we press enter, it's going to give us a little status indicator about how it's doing. It says, I'm 97% done. I've estimated about 3 seconds to go. Wow, almost done. So this is giving us a bunch of details. Primarily, this is when we said safe or default. So in the safe group, there's dozens and dozens of extra queries that are going out to get that information from that system. So it's always interesting the amount of information that can be retrieved, and these scripts are a powerful tool. As I mentioned, I think there's close to 200 that are included with Nmap, and then there's hundreds more that individuals have written that are easily found and downloaded, so you can use them for additional information gathering using Nmap. In the Nugget Lab download area, I've got all the commands that I've demonstrated and more in this Nugget series. So you can download those if you want the actual commands to practice with them. But for some individuals, they find the command line a little bit tedious, especially if they haven't worked with it a lot. There is a graphical interface called ZenMap that we can also use for Nmap. Effectively, it's the same Nmap commands. It just gives us a nice, beautiful graphical user interface that we can use to check boxes, put in IP addresses, click on go, and not have to do quite as much typing. There is one more command line option I'd like to share with you before we take a look at the GUI, and that is the -A option. Let me get my pen out. This -A option is power-packed. You can think of it as all. Maybe it means all. I'm not sure what they're thinking when they gave the A, but the A represents that we're going to do a script, so it's like a -SC, the default script. It's going to do the operating system and version extraction to the best it can. It's also going to do a trace route as well. So that's all that information coming from that -A. And the T4 is regarding timing. So we're doing fairly aggressive timing, not waiting a whole bunch for the results to come back. And the response hopefully should come back within 30 to 60 seconds. And it is done. There's the results right there. So it took 37 seconds. So some of the details that it just got for us, it got information regarding the operating system it thinks it's running. It also got information on the web page for administration that this Palo Alto firewall has, as well as some of the details for SSH2. It also identified, or it believes under the covers, that this firewall is running a flavor of Linux that's 2.632 to 2.633 based on the fingerprint of what it could detect that device was running. And here's our results of the trace route, which means there aren't a lot of devices in the path because we are on the same exact IP subnetwork as that firewall. There is a graphical user interface counterpart to Nmap. It's called ZenMap. It still uses the exact same logic of Nmap. It just gives us a graphical interface so we can put in IP addresses, click the options we want, click a button, as opposed to having to press enter to launch the actual scans. So let's close together our Wireshark that we had from earlier. And I'm going to say quit without saving. We can regenerate that anytime we need to. To actually bring up ZenMap, you probably just want to bring up a console and type in ZenMap. Enter. That would bring it up. But if you want to click to it, you can go to the backtrack and information gathering, network analysis, identify live host, and go down to ZenMap right here at the bottom. So I think the command line would be a lot faster than finding it here, but it's there either way you need it. So we'll go ahead and launch ZenMap, and let me minimize that console window as well, and let me maximize ZenMap for us. So take a look at the default of what it wants to do. It says Nmap -T4, that's the timing, fairly aggressive. -A, that's all those things that we just looked at the command line, including the default script, and the -V is for verbose. So all we have to do is put an IP address here like 192.168.1.6. That's the device I know has some open ports. And we click on scan, and it's off to the races. Now, if we don't want to do an intent scan, check this out. We can go under Profile, use the drop down, and we can select anything we want. We can do a quick scan plus, and they're going to give us various details of information based on that. So if I did a quick scan plus, So it's doing T4, fairly aggressive timing. The -F is the 100 most popular ports. That's great. Let's go ahead and launch that. We'll click on scan, and it runs. And there's the results. Nice graphical user interface for Nmap. And if we want to do a more detailed scan, or if we want to scan the entire network, we could do that. We'll go ahead and simply say, I want to scan the 192.168.0 subnet /24, and simply hit scan, and it will run. So in the background, it shows us the scans that have happened. So we have this scan that happened earlier. Now we have the scan that's currently running. And if we also want to go ahead and look at the individual details of hosts, once the scan is done, they'll all be here on the left. So if you see all these devices are popping up, that's just because that scan just finished. That's the entire subnet. So if we take a look at Nmap output and we want to click on a single host, it'll take us to the details of that host in the output. It's very, very convenient to sort and look things up right here in Nmap using exactly this. So if we want to go to ports and hosts, we can click on any device we want for a Reader's Digest version of those ports. Look at that guy. .19 has all those ports open. And if we look at .6, this is a little Netgear wireless access point. And if we look at topology, check this out. I'm going to go ahead and grow this a little bit. I'm going to wheel it up with my mouse. And there's various ways of looking at this as well. Now, these are all on one subnet. But if we had networks that were not directly connected to the same subnet, we could see the actual router IDs, the hop counts, I should say, of the routers between us and those destinations. One other thing that I really like about this tool is that we have these profiles, but the profiles, you don't have to just accept the defaults that come with ZenMap. If you want to make a new profile, you can. Check this out. We'll go up to Profile. We'll say I want to create a new profile, and then you can specify exactly what you want to do. Then we say, oh, do I want to use the -A? You click that button. That's all you have to do. As far as the TCP scan, you can select the flavor that you want. It'll actually build this into your profile. So if you have 2 or 3 scans that you like to do all the time, you can put them into profiles, and then you select that profile and launch it. It's also a great way to see all of these options here. So as you hover over any one of these, it tells you over here on the right the details for that and what that means. So here's scripting. Check it out. So if we knew we had some script that we wanted to include, look how easy it would be to do it. We simply click on it, and it will go ahead and create the actual syntax for us. So if this goes into our profile, we just launch the profile, put in the IP address for subnet, and we're good to go. So it's a wonderful learning tool. It's also a wonderful way to optimize the actual groups of commands that you intend to use on a regular basis. In this video, we've taken a look at what Nmap does, an example or two of how to use it, including scripting and using ZenMap. I've had a lot of fun. All of the commands for this nugget have been loaded up into the Nugget Lab download area. So if you want to review those for practice, all you need to do is swap out your IP addresses on your private network that you want to practice with, as opposed to the ones I used in this demo, and you are good to go. I hope this information has been informative for you, and I'd like to thank you for viewing.